Good evening, everybody. Welcome back to another episode of Wrench Tales. We're on episode number 10, and I'm with my good buddy, Jon Hufnagel from Butler, PA, just outside of Pittsburgh. Jon is a mobile diagnostic solutions provider out in the Pittsburgh area. And Jon encountered a very strange problem. I've never heard of this problem before. But before we get started, I do want to say, Jon, thank you so much for taking the time to meet with me, my friend. How you been?
Good, good. Thank you. It's pretty
Good.
cool to be on here.
Oh, I'm glad you are, man. Especially, I remember this truck. You were telling me this story a couple of weeks. Actually, it might have been a couple of months ago now. But
Yeah,
you know what I loved about it is it wasn't an easy solve, and there wasn't a lot of disassembly, which is the best part. It was mostly the research,
yeah.
that got the car fixed, and that's what I really liked about it. That we spent most of the time thinking about the tests we're going to do, and bang, we implemented a couple of tests, and you found your problem, and as usual, you were the hero. So, Jon, give me the rundown here on this Ram, this energetic Ram that just will not quit. Tell me about it.
I believe it was a 2017 or 19.
I think
I
you're
don't,
right.
can't remember. Somewhere in that range. The garage called me up, said that they got a truck that won't shut off. It started, drove, ran fine, but when they hit the push button start, it wouldn't shut off. They were able
No,
to I think they put the parking brake on or something, and somehow it shut the engine off. But
oh, so the engine wouldn't even turn off when you're pushing the button.
no, 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 it stayed running.
No kidding. That's different. So I remember you telling me the story, and again, I'm asking again so everybody else can hear what you told me. But so you get in this car and you push the button, and the engine won't shut off, or maybe not you, but the shop. And then they figured out if they apply the park brake, they could at least get the engine to shut off. But you couldn't shut the vehicle down, right? It stayed
Nope.
alive and awake, and
Yep.
that's strange.
Yeah. Yeah. It
So
was definitely strange.
so do you know what was attempted? Did they even bother trying anything, or they just call the hero in right away?
I don't believe they were lost. They had no idea what to try. They thought it was module being bad, but they weren't sure what one.
Right.
So
Anytime you have a problem you can't explain, it's got to be the computer, right?
yeah, yeah. It's the first thing that everybody says.
I remember my mentor told me decades ago, when fuel injection, computerized fuel injection came to be, every time a car wouldn't start, everybody blamed it on vapor lock. It has to be vapor lock.
Yeah.
And then it became the ECU.
Yep. Yep.
So this unfixable car you're faced with now, tell me some of you arrived, right? What do you, on your way over, if you got that phone call, what were you thinking in your mind? Like, I always, when I got mobile calls on my way over, I'm in my mind, I'm thinking, where do I want to start? What clues might I be looking for? What did you anticipate running into?
I anticipated it just being a bad push button switch.
Yeah.
But then I started looking at wiring diagrams and noticed that it's on a network or
Mm.
CAN line, and it started the truck fine. So I knew it wasn't a bad switch.
Well, I'll tell you what, Jon, I've been around. How long switch push button ignition's been around now? 20 years more, maybe?
Yeah, yeah, somewhere
About 20 years, give or take.
I would say somewhere around there.
I can count on one hand and have many fingers to spare on how many push button ignition problems I've encountered in my career. Very few, like two or three ever. So this is, for me, this is just a strange problem to begin with, no matter what car, no matter what symptom. Um, an issue with a push button start, or in this case, push button no turn off, is a strange issue. So what did you notice? You get to the car. Um, these clues, like, what did you look for before you got started? Obviously, you wanted to give a quick once over to see what you know before you get started. But what did you notice
Uh,
about this car?
I just started pressing buttons, trying to get it to shut off, but it wouldn't shut off. So uh, I think I looked on Google and Identifix, and I couldn't find somebody that had a similar problem. So then I started looking at wiring diagrams, I believe, and
Gotcha.
then scan data. Of course, I couldn't find any codes or anything to lead me in a direction where to go.
Well, when you told me on the phone that the truck wouldn't shut off, I thought in my mind, like, is it in park? That was the first thing that popped in my mind. But obviously, I mean, you're an experienced technician.
Yeah,
The chances of you not knowing it's in park are slim to none. But you mentioned a message. Didn't you notice something on the dashboard?
yeah. On the dashboard, it said vehicle not in park, but the Prindle clearly stated it was in park. So then I looked at scan data, and it every module that listed the transmission, the range indicator, it all listed it was in park.
So that is a really big clue. And I don't know if you're about to say something. I didn't mean to cut you off,
No,
John.
no, you're good.
These are the things we don't think about. We sometimes, especially a tech that's just getting into diagnostics, in a situation like this, they see something, a message on a driver information center or a heads up display that says vehicle not in park, like a warning to you, that hey, it's not in park. You definitely don't want to get out of the car because it might roll away. Um, if that's all they noticed, they might chase that. But to take time to see that the Prindle, the park reverse neutral drive low indicator, shows that the vehicle is in park, and the fact that you're able to start it um, in this same state, it could be a clue that the vehicle is in fact in park. Now, if you had a message that said vehicle not in park, as you do in this case, but the Prindle also showed that the vehicle was not in park, and perhaps you had the symptom that it wouldn't start, right, as a safety precaution. I'm sure you would have headed in a totally different direction. I
Oh,
know I would
absolutely.
have.
Yep.
Yeah,
Yeah, I probably would have went to the transmission range sensor.
yeah, and my mind is headed in that direction. I don't know, of course, on this vehicle where these components are located. That's always what I'd like to know before I get started. But factoring all that out in my mind, where might this problem be found? And that's one of the first places I would think of too. But we didn't have those symptoms. We didn't have a no start situation. And the Prindle and all of the parameter identifiers and all the nodes that actually listed shift or gear shift or trans range status showed that it was in park. And the fact that the vehicle is not moving, right? It's being held
Right.
physically in place. We're kind of confident it's in park.
Yes.
So you mentioned that this module, this computer that processes the shifter, and we'll find out in a little bit that it's called the electronic shift module, the ESM. Um, you mentioned it's on a network, but you have no network DTCs or anything like that, right?
None. None.
So no inability to communicate. And that's what I like too. It's also a really big clue. Um, it helps you figure out what we're not going to waste time testing, and that's something that helps my efficiency as a diagnostician. Once I got to the point that I was self-aware and also aware of why my diagnostic approach existed as it did, I realized that I used to try to fix the problem when somebody handed me the keys, and now I don't. My primary goal isn't to fix the problem. My primary goal is to where do I not where do I avoid testing because I don't want to waste any time. And I found when I focused on that, once I narrowed down to the few things that I did find myself testing, it only took a few minutes and it wasn't very difficult. So what's your approach, John? Walk me through this here. This
Um,
problem, right? This is new to you. I've never seen this before either,
yeah,
right?
yeah, I've never seen it either. And that's why I told him, I said, I don't know if I can fix this. I couldn't find anything on the internet or any vehicle repair websites. So I wasn't sure if I could fix it. But
I get that.
trying to think where I started at. I've got in touch with you and we discussed about the network, about the shifter, the switch for the gear shifter, on what network it was on. And you advised me
Absolutely.
to check the signals on the network. So that's where I started. And at the shifter knob, the signals were perfect.
Gotcha. And I mention that for good reason because as you know, as I'm telling everybody that's listening here, I am not intimately familiar with this vehicle. I've never worked on this year, make, model platform before, and certainly not this problem or with these components or how this system's configured. So I myself, even if John reached out to me for some input, John, you recall that conversation? I said, let me do some reading and I'll call you back. Do you remember that?
Yep. Yep.
And I had to educate myself. John
Yep.
was turning to me for maybe some input, and I had nothing to offer. So I had to do some just-in-time training myself, and I did that by researching service information. I wanted to find out. I call it, who are all the players in the game? What are the components that make up the system? How do they work together to accomplish the goal? And what's the goal here? To make sure the vehicle's in park and to report that to other computers so it can be displayed for the driver. If it's not in park, for instance, that we want a warning to pop up. So I have to do that kind of research. How that system is configured. What I mean by that is there's way more than one way to skin a cat. Look at a basic horn circuit, John. Years ago, we would lean on the horn pad and provide a ground path for a relay coil. The relay would energize and become a magnet, and when the contacts close, it would feed a horn, voltage. And that horn's always grounded, and in the end, it goes beep beep beep. Fast forward 15 years, that horn pad is a ground path, but it's a ground path for a signal to a computer. And when
Yep.
that computer sees that horn input, that request to blow the horn, it gets on the CAN bus and makes a phone call out to another computer, which then drives a relay. But in the end, 10, 15, 20 milliseconds later, beep, 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 you and I don't know the difference. So we need to find out how this system's configured. And we're going to find out through wiring diagrams and service information. You mentioned it being a network. So in my mind, if we had any kind of network issue and signals weren't getting where they're supposed to, when I say the signals, I don't mean hardwired signals. I'm referring to bus network, telephone messages getting carried out. And finally, where do we want to carry out the test? What test do we want to do? How do we anticipate the test results? And where are we going to carry out those tests? Because, on paper, everything looks good, but to put our hands on some of these components sometimes can be real nice. So my approach, John, and I'm sure yours, being a mobile solutions provider, efficiency is in your best interest. I know that for a fact.
Yes. Yep.
So we're gonna do the easy test first, gather what we can from the scan tool, and at this point, it sounds like you've done just that. You've given me the information I needed preliminarily. There's no communication faults. You have no DTCs pertaining to this system. Nothing pertinent. You don't appear to have any communication issues, and every node that you've researched that shows transmission range switch status, in fact, shows it's in park. But the clue, the takeaway that you and I have to run with is the message that says it's not in park. And whoever is watching that message is the one not allowing the vehicle to power down. So that's the things we have to consider. Following the clues, the basic clues that we can gather by doing customer interrogations, or in this case, I'm speaking with John. I'm asking John questions because I'm not there. But ultimately, I want to find out how that transmission controls park, right? How do we get it in park? And how is that information relayed to other nodes, right? In other words, the heads-up display or the driver's information center, what have you, maybe the Prindle, the PCM, all of these computers need to know this information, and how that information gets there is dependent upon that vehicle's configuration. So, John, here's a little tip I have for everybody at home. And the reason why I like to offer this tip is my perspective has changed a little bit. As you know, I'm not in the shop full time anymore, John.
Yep.
And I indulge my enjoyment of diagnostics by living my life vicariously through friends like you.
Yeah.
But I love it when people call me for some input, for some technical assistance, or maybe I can do some research for them because it's going to take them a lot of time. I'm happy to do it. But with that, um, I'm proof. I'm the proof that's in the pudding. You have to divorce yourself from the vehicle. John, how many vehicles have I showed up to and stood next to when we solve some issues? None, right?
None.
Nope.
Nope.
I've never worked side by side with John, but we've always shared information similarly like we're doing now. So divorcing yourself from the vehicle is what I like to do where I can focus on the information. Understand that when you take yourself away from the car, that stress, that pressure is gone. And then you can use your mind to make diagnostic decisions. Now, I'm going to warn you, it feels counterintuitive. You feel like you're wasting time when you could be working on the car. But simply running around and taking things apart, hoping to find a problem, is not good time invested. If you're taking things apart because a test guided you there, that's a totally different scenario. And I say go with it. But I don't like taking things apart as experiments. So we need to focus on a test plan and simply walk up to the car and carry out those tests. And you're looking for the answer to that test. And you want that test to carry you out to your next logical test in that procedure. It prevents you from skipping over important steps and missing data. And on top of that, every test you perform is justified from the answers of the test you just performed. So I did some research, John. And if you recall, I wanted to find out how this shifter, right, this what we're calling this electronic shift module, how it does what it does. And that's what I found out. It's nothing more than a switch. We are nowadays we're dealing with electronics more than mechanical operations. So I'm not going to show all the literature below this, but I happen to be using AllData, and I'm not here to support AllData or any other service information system, but this just happens to be one I'm comfortable with. And through the description and operation, I discovered, like just how John mentioned, this shift module is nothing more than an ECU that processes a request from this switch you see here. And with that, that module sees that information and shares it on a bus. Now, through this same literature in the description and operation, I've learned by way of this fin that this vehicle is equipped with an e-torque engine, basically a mild hybrid assist for added torque to support the internal combustion engine's output. Um, that's something you're going to need to know in a little bit. But that this electronic shift module, I'm just going to call it an ESM, does in fact communicate, just like John said, on a network. But I took for granted that it's the CAN-C bus because every vehicle out there nowadays has CAN-C, which is high-speed CAN network, because it has to be there for OBD2 global reasons. It's the law. OBD2 certified vehicles have to have CAN-C on Terminal 6 and 14. But what I didn't realize was after I clicked on the information system, the information bus hyperlinks, there are 4 different distinct communication networks on this vehicle. And I'm not sure if all or some or any or maybe just one, maybe that information John is seeking is only shared on the CAN-C bus. That is something that definitely requires research, and the engineers can make any control module do anything they want it to do. Heck, we can make the shifter operate through the radio if that's the way the engineers design that to happen. So we really, really need to research that. And you can't just take the knowledge you have from previous vehicles and apply it to this one. You have to treat every vehicle like its own infrastructure. So I do some research and I went right to the shifter. And John, what does this solid black line mean to you? Like
That
here's a
means
dot.
that means they're showing everything on that module or item. There's
You
nothing
know,
left out.
I love that. I love when I encounter something like that because I know everything I need to see is on this page. And this
Yep.
shift module is a very simple device. It's fed fused voltage, current flow through a fuse 42, and then through one of these over here. It's a little bit fuzzy. I can't see right now. My eyes are terrible. Sorry. Um, it has a ground and it simply communicates. That's all it does. It takes the signals from John's shifter and it sends it out. Now, what I see here is the CAN-C network. I'm not sure if I need to zoom in on this, but I will. We've got the CAN-C network here, and that allows the shift, the ECM, sorry, the ESM, the electronic shift module, to communicate on the CAN-C bus network with the CAN-C IP, standing for instrument panel, the IP star connector. And star configuration is almost like a comb. It lets us take multiple branches and connect them into one spot. So I really like when something like that is available when we're dealing with CAN diagnostics or network faults. But here's something else I didn't anticipate, John, and it certainly was not listed in service information, but we have the private CAN network. So this is also a CAN bus, but it's a dedicated or private CAN bus, and that's something I am going to have to read about. And then I have the transmission control module that this connects to, but I also see that the trans module is also on the high-speed CAN network, and it passes through another star connector. This one's called the CAN-C dash, as in dashboard, dash star connector, or this one's called the IP, as in instrument panel, star connector. So I see how the ESM communicates through the trans module, through the CAN bus. However, I don't know how the signal from the ESM gets anywhere else. And what I mean by that is you'll see with the research we did coming up. But what we're facing here is what we found out just now. We definitely know the ESM talks on the CAN bus, but of these three paths, I don't know which one is being utilized to deliver the ESM message to the trans control module and perhaps to the rest of the vehicle, like the cluster and the message center and things like that. So I decided to start clicking on some of these buses and reading about them. And here's where I got a little bit confused, John. Here, when I researched CAN private bus, remember I mentioned this vehicle, we've proven it has eTorque, right? We cross-referenced it to the VIN. So we have that eTorque setup, which means we have to obey everything in this gray area. This gray area is for factory use only, so we don't have to concern ourselves with it. But here's what I'm unclear about, John, and if you know the answer to this, please tell me, because I certainly don't know. Matter of fact, if anybody at home is watching this and wants to comment in YouTube, the comment section, let me know. I don't know if the possibility is like this. Since I have eTorque, I only have to focus on this area. Or perhaps it goes something like this. I still have to concern myself with this, but since it has eTorque, I also have to concern myself with this area. I truly don't know. So at this point,
I don't know either.
Right? Do you agree with me? Like, do you see that it's not very clear?
No,
So
it isn't.
At this point, I actually was saying to myself, I said, man, I can't even call John back yet because I don't have a definitive answer. And I certainly don't want to be the guy that goes, sorry, John, I can't help you. Hey, let me know how you make out. Right? I hate that. It happens sometimes.
Yep.
Sometimes I don't have the information I need. But I'm not done yet. I decided to think things backwards a little bit. So I thought to myself this: the real problem we have is that the vehicle won't go into park according to our driver's information center warning message. However, on the flip side of that, the vehicle does start. So I thought to myself, you know what, John, let me work backwards. Let me go to the starting system wiring diagram and see if I can gain some insight there. So here's the starting system overview, and many service information systems are laid out this way now. They offer you the entire vehicle at a bird's eye view on one page, and you zoom into the area that you desire. So I'm purposely showing you this, not that I expect you to read any details, but this is a layout of this, just the starting system alone. But I found the area I want, so we're going to zoom in on that. And here is our ignition node, right? John's push button, the push to start button. And if we were to zoom in on this, we would see that this keyless ignition node is fed voltage and ground. And again, much like the ESM, that electronic shift module, it simply delivers messages. We've got a security K-line communication network, a dedicated line here. But this one, the ignition switch sense, this is what's being reported when John pushes the button. And it reports to a device called the radio frequency hub module. Now that hub module delivers the transmission range switch park signal to the body control module. It is a discrete signal. It's either going to be high or low. And this is the signal, I think, that is responsible for a problem. And this is about the time I was getting ready to call you. I wrote this down, John, and I decided to do a bit more research. So now I see how the park range switch signal gets to the body control module. We just now have to determine how the signal is shared between the body control module and the rest of the vehicle. And I think we're going to hit a home run after that. Does that approach make sense to you, John?
Yep, absolutely.
So I wasn't really sure this time, but that's the way I went. So I decided to look up the CAN's network, and the same thing. We've got a CAN overview. We're going to zoom in. And once I zoomed in, I hunted down the body control module, and I found that first. So that's what I have circled here. And that body control module has the CAN-C, the high-speed CAN network, both high and low, that reports to that same, you guys remember that IP, that CAN-C IP star connector, the one in the instrument panel. And that information is shared through that star connector to the electronic shift module. So that is how the information is shared from the ESM to the body control module. And now that we're on the CAN network, this message can go anywhere we want it to. So just things to keep in mind. Here's the trans control module, or the powertrain control module, the drivetrain control module, right? Whatever module needs that information can get it, because it's all on the same network, the same party line. So now we've got our plan of attack. And John, you attacked the vehicle. What did you do?
First thing I did was find out where the radio frequency hub was located. And
Where was that located?
It was behind the back seat on the back wall underneath the back window. And there were TSBs. I don't know if it was a TSB or just a video I seen about water leaking from the window down into the module. And I didn't see any evidence of rust or anything. So I was very doubtful that water was the problem.
Understood.
So, like I said, I took the interior panel apart and got the module and started checking signals. Or first I checked power and grounds and then signal. But I noticed on the go back to the last screen, that transmission TRS signal that you got highlighted.
Yeah.
I wasn't sure how or what it was supposed to look like, but just from experiments, I put it in drive, or in actually any gear, and it went 12 volts. And then whenever I put it into park, it dropped down to 0 volts, but it wasn't zero. It was a sawtooth pattern like you had. Yep. Right there. And I didn't know if that was normal or not, but I didn't think it was.
I'll tell you what, I concur 100%. I've seen this several times. And what I do want to point out is this. Obviously, this is a quick screenshot you took with your phone of your scope. Excuse me. Of your scope. But even if we didn't have the numbers here, you and I know this is not something logical.
Nope.
The way this waves like this. This is a problem. And you know what, John? I recognize this pattern frequently when maybe my scope ground reference has popped off.
Yeah.
Right. An alligator clip goes snap and it goes flying, or I'm on a hunk of corrosion and I got to wiggle it to get a good bite. I've seen this before. So right away when I saw this, I knew we had some kind of floating ground issue. And here's the logic I use. When I saw these numbers, I thought to myself, if this is supposed to be a 12-volt signal, you are losing almost the entire signal. I mean, 11.5 volts is missing. But you said in drive, it comes back to 12 volts.
12
So
volt.
it's highly unlikely that it's a voltage feed issue. But the fact that you lost ground would cause, or poor ground would cause this to elevate. And this is roughly 400 millivolts. So again, I'm agreeing with you that it is likely a discrete 12 volt or 0 volt signal, darn
Yep.
near 0 volts. We could just call it high low, right? Digital signal. And you've lost the ground. So I guess the next step, I mean, I don't want to call this a home run yet, but you're going down this path for a bad ground. Um,
Well,
we got to find.
at first I thought I was AC ripple
Gotcha. Okay, yeah,
because
makes
it
total. Tell me
does
about
look
that. So
similar. So then I
it
headed
does.
underneath the hood, checked the
Hmm.
alternator. The alternator was perfect.
Good, and I'm glad that didn't take much time either. But you
No.
you have a valid point. Um, AC is supposed to be filtered. When I say AC, meaning alternating current for you younger techs who don't yet have that experience. An alternator produces AC current, AC voltage on three different phases, and it's that diode bridge, that diode trio that rectifies and takes that AC and blocks it through those one-way check valves. And under full rectification, brings everything above the zero line. And that's what gives us our average of about 14 volts, give or take. It depends on the system, but gives us that DC component to that alternator's voltage output. When those check valves, those diodes go bad, we get what's called AC ripple. And it's almost like leakage, AC voltage leakage out of the alternator. And I'll use the word contaminates the rest of the vehicle because the vehicle can't recognize these as normal voltages, normal voltage amplitudes, and it wreaks havoc on the electrical system, especially electronics. But man, I'm right on top of this with you, John. When you called me and said, "Look what I found," I was like, "Wow!"
Mhm.
I knew you were going to fix the car. So with that, I mean, we've got a couple of possibilities. If we go back, let me go back a minute. We go back, we've got our BCM and we've got our radio frequency hub, and we don't know which one of these, we don't know if this is a pull-up circuit that goes from the radio frequency hub to the BCM, or it's a pull-down circuit that the BCM supplies the reference voltage and the radio frequency hub pulls it down. With that, we don't know which control unit has the bad ground. So we're going to have to check them both. But what I love here with service information, again, giving us that ability to build a test plan. We found our ground identification, and there's our radio frequency hub. And we can see that it's linked up through a splice at G946A. Sorry, my eyes are terrible. We might want to go there. I'm definitely interested in it, but I don't know where it is just yet. And there's our BCM's ground location. That's what this says here. This is G921A. So rather than running around like chickens without heads, let's just stay here and do some research. And this is where we found these locations. Well, here's 946A. That's underneath the vehicle, between the bed, the back of the bed, sorry, the front of the bed and the back of the cab. Might be hard to get to, might not be hard to get to. But I can tell you this, there's our 921A right up there in that fender line. Right? That's easy to get to. So I always try and do the easiest first. And John, again, being a man of efficiency, that's your job to be efficient. That's how you
Yep.
keep the revenue coming in. It
Yep.
makes sense to attack this first. That's exactly what you did, isn't it?
Yeah. Yeah. I only had, minus taking the seat out. Uh, I think I was there for 2 hours.
I love it.
So
Beautiful.
it didn't take very long to figure out.
Very good. So looking at this, first of all, you put your scope on this and saw virtually the same exact waveform, didn't you? Is that what
Absolutely.
you told me?
Yep. Yep. On the
Now look,
terminal, on the wire or the ground terminal, I had the same signal. I put it on the
gotcha.
nut or the bolt, the stud, and I had a flat ground. So I knew I found my problem.
So if you put your lead here, you had noise.
Yep.
You had that sawtooth pattern, and if you put
Yep.
your lead here, everything was a-okay, right?
Yep. Yep.
That's a distinct problem right there. And that's the
Yep.
thing. These weren't loose or
Nope.
painted or tampered with, were they?
Nope. They were tight.
Love it. But when you pulled that nut off, you found the problem, didn't you?
Yep. Bunch of rust.
I
I don't
love
know
it.
why, because as you can see, it's painted. There's no damage. but somehow rust got behind there or in between the nut and the wire and rusted up.
Beautiful thing. That's awesome to go in there with this problem that evaded other shops and other technicians, and you simply go in and the repair is to clean up a little bit of rust on the end of a cable,
Yep.
and you fix the problem. Now, I know I'm going to regret asking this, but you don't have the after captures, do you?
No, I don't. It's
Hey,
just a normal ground.
sometimes we get lucky.
It's just a
You
normal
know what, John?
ground on that one.
I'm going to take your word for it. I always like to show everybody the before and after pictures and explain why it looks the way it does now compared to what it looked like before, because I want them to make sense of it. But providing that ground path, a couple questions I had for you that maybe we can discuss this. Why, if you lost the ground to that body control module, which is what this ground supports, that supports the body control module. The ground underneath the vehicle was the one for the radio frequency hub. Sorry, that supported the radio frequency hub. Why did this BCM continue to communicate if it had a bad ground? These are questions that pop into my mind. You know, others do as well. And I have some thoughts, but what do you think?
To be honest with you, I don't know. You would think with a background, you would have a ton of codes for just random codes. So I'm not sure why it's still communicated with no issues.
You know, and another thing you have to consider is sometimes there are multiple ground terminals. And maybe this one doesn't carry much load. It was simply a ground circuit for signals.
Oh yeah.
Whereas any other ground on that body control module connector may have supported the operation of some load devices like motors and solenoids and
Right.
other actuators like that. So again, I asked that probing question simply to bring it up so we can talk that, hey, listen, here's why this may not make sense to you and one of the other possibilities. But John, take us through this real quick now. Like your approach to solving problems like this. It's not so much that the car is fixed. I knew you were going to fix the car. Otherwise, we probably wouldn't be talking about this on Wrench Tales.
Yep.
But it's the approach. That's what I'm trying to help share around the industry.
The major clue was the screen saying it wasn't in park, but everything else says it was in park. So that was one of the clues.
So putting these puzzle pieces together, I mean, what I like about that approach that you're doing, John, is we're not wasting time testing things we don't have to test or taking things apart we don't have to take apart it. And even though we're standing still and it looks like we're wasting time, we're investing the time where it needs to be invested doing research and not investing it taking things apart that aren't going to yield us an answer or simply just going to take up time for no reason. So you're doing that before you dive in. As slow as you may appear to be, in the end, you got this car rectified in 2 hours, diagnosed and repaired in 2 hours. That's pretty remarkable, my friend, especially a weird problem like this.
Yeah.
You know, so
Yeah. I
and
was
that
quite
includes
happy.
calling. Yeah, I very, very impressive. Very impressive. But it's simple. When I say simple, I'm not discounting the fact that John's a very knowledgeable and experienced technician. But what I mean is the approach is simple. We educate ourselves, so we learn about the system. We know how the tools work. We have some knowledge about how these individual components work, like solenoids and switches and communication networks and ECU control. And with that, we come up with an idea of what tests we need to perform, where we need to perform these tests, and what we should anticipate as far as answers if things are working as they're supposed to work. This way, when they don't, we recognize them as a fault and we can pursue those faults by asking ourselves another question. Why would it report like this? So I love it. In the end, John, you just let the test guide you to your next one.
Yep.
You know, and I do the same thing. And you know what? After speaking with hundreds and hundreds, I might even say thousands of diagnosticians across not only the United States, but all over the world, no matter what country we're from and no matter what language we speak, the approach to these problems, the successful approach, um, typically is very, very similar. And that just tells me we're on the right path. I hope that makes sense to you.
Yep.
John, I do want to thank you again for joining me on this episode of Wrench Tales. It's an honor to have you on. It's always great talking to you. I wish I got to spend more time with you more often. It's terrible. I only get to see you a couple times, uh, maybe once, twice a year if I'm lucky at some of
Yep.
these
At
events we
training.
train at across the
Yep.
country. But hopefully one day we'll be able to spend some real time together.
Yeah. Yeah. Go quad riding, or you ride dirt bikes.
Yes,
Something.
sir. That's my jam.
Yep.
But John, thanks again for taking the time. I appreciate it. Everybody, this is my good buddy Jon Hufnagel from John's Mobile Diag out in Butler, PA. Thank you all for watching this episode of Wrench Tales, and we will see you on the next one. Take care.